JMU, as an institution and university, has a past, present, and future connection to trains and railroads as one goes right through campus. Back in May of 2017, a train actually derailed off of campus, spilling grain corn, uprooting trees, and damaging power lines. Our capstone team decided that the problem we would tackle as a group would be derailments. How might we limit them based on defects in rails? A few ideas came to the front of our minds. First was flying drones over railroads in order to inspect them visually with cameras. Another was mounting sensors to already operating trains that would constantly be scanning rails for defects. Another idea was to remotely operate a vehicle that would be controlled by an inspector to evaluate railroads. Well, finally, we ended up deciding that a redundant autonomous inspector would work alongside manual inspectors. After our ideation phase, everything changed, of course, with COVID. There were many impacts to our capstone team. One being a limited time in the lab to use resources. Two, having fewer interpersonal development activities sponsored by Cassidy. And three, a lack of connection to campus and team members. Given this, how did we go from ideation the previous semester to our first alpha structural prototype? Let's talk about that. In Train of Thoughts, Episode 2, Our Story.
Hi, and welcome to our capstone, Autonomous Inspection System for Railroads. It's time to meet the team behind the project. I'm Cassidy Anderson, our project manager. My role entails keeping things organized and knowing what's going on between our subteams so they can work in tandem. We have two subteams, an electrical control subteam with Jake, Ethan, and Lachlan, and a structural mechanical subteam with Adam, Trevor, and Zach. By keeping track of the work in our subteams, I'm able to plan ahead for our project, make sure everyone has access to the information they need, and keep us on track. I've utilized knowledge from management and leadership classes, along with observation from managers at work to create a management system that works for our team.
As we go through the rest of this video, you will see, after each member's contributions, this functional model, as well as a data functional model, appear. Each member's contributions will be related to each function within the system that they have helped contribute to.
Now that you know more about the team, let's hear from our other members.
Hi, I'm Jake Hinkle, and for my contributions to the embodiment of our capstone, I've been working on the object detection subsystem using a Raspberry Pi and connected camera. This includes downloading all the necessary libraries to create and train an object detection model, which can work with the appropriate software for a lightweight processor. The biggest obstacle I've faced is debugging the code for the training model and making sure I have the correct resources for this design in specific. And that's the stage that I'm currently at.
Hello everyone, my name is Lachlan Hudson. My contributions to this capstone project began with a design of a schematic block diagram of our electronics, as you can see on this slide right here. Following that, I was able to put together a MATLAB multi-objective optimization problem where we were weighing the efficiency of loading based on Delphi panel results that we got feedback from experts involving cost, weight, and power efficiency. Following that, I was able to do safety factor calculations on different connectors we would be using in our electrical system, while then finally putting together some rudimentary components in order to determine what steps we can take next in order to create an actual electrical board for the design.
Hi, I'm Ethan Keck, and for my contributions to the embodiment of our capstone, I've been working on the design of the electrical subsystem and finding resources for controlling our electrical components. This includes creating a block diagram of the electrical components to get an understanding of how all of the components will be wired, measuring the current prototype of the physical model to know how much wire we need, and researching encoders. Another task I performed was doing hand calculations on how fast our design could go while maintaining overlapping images with the frame rate of our camera, and also figuring out how far to put the camera away from the rail. The stage I am in right now is finding resources that can explain how we can mount our encoder to our design, where to obtain an encoder from, and finding tools on how to program the encoder.
Hi, my name is Adam Zahorchak, and as part of the mechanical subteam, my role required me to design, analyze, and prototype the chassis of the inspection vehicle that we plan to build. In the top left, you can see initial drawings of the frame that were done on paper. After that, a 3D model was drawn up in SOLIDWORKS, and then analysis of the design was done through FEA packages in SOLIDWORKS to determine maximum stress under a specified load. After analysis was completed, it was determined that the frame would be able to support the mass of the system as a whole.
Hi, I am Zach Wensler, and I am on the Inspection System for Railroads capstone team. So I am on the mechanical sub-team of this capstone, so I work solely with the structural and mechanical aspects of our design. And this past semester, my contributions to our team include finalizing and creating the CAD model for our physical frame prototype. Another contribution that I've done was created mathematical idealizations about the frame itself. This is so if there were to be anything changed about our prototype and the design, it could be solved in about a day, as opposed to taking the time to recreate all the new math. On this slide here, you will see our condensed mathematical models based on the tributary loading, gears, and the free body diagrams of the beams. The last major contribution that I've done to our team this past semester was helping construct and create the alpha prototype. This is to ensure that everything will function properly on the train tracks and that the camera mounts will be safe and secure and also functioning properly.
Hi everyone, my name is Trevor Kreitler. My role in design embodiment includes being the team communicator and budget manager. For these roles, I developed a bill of materials of parts we will need for the project, and I facilitated workdays to build a camera mounting prototype and frame prototype. We wanted to test the frame to ensure our SOLIDWORKS drawings were accurate. So, to do this, we purchased axles, wheels, and ball bearings, and built the prototype frame from wood according to the dimensions we laid out in the SOLIDWORKS. This was a cheap and feasible way to ensure our concept worked. Ultimately, enabled the team to define building procedures and codes for the team to follow later in the design build stage. As team communicator, I have contacted Shenandoah Valley Railroad to collect images of their track to build a larger image database for object detection. Having more realistic images of railroad track can help train the system to take into account for weather, leaves, sunlight, grass, and other track configurations such as switches, roads, or derailers. Doing this will allow our system to be more accurate when detecting the rails, and I'm proud of the accomplishments we have made thus far.
Our story is not yet finished. There is still more work to be done. First, we plan on incorporating a new camera mount for our design. This will hopefully be able to hold the camera at certain heights and certain angles above the rail in order to get multiple images of distinct locations on the surface of the rail to detect defects. Second, we plan to upgrade our frame. No longer using the wood structure that we have currently, we will be using an aluminum frame. Finally, we hope to finalize our object detection and incorporate that into our design so that we can start scanning real-life rails in order to determine how well our design meets our problem. Next, we have a way for you to contribute to our story and make it your own. First, we have a previous episode from our capstone project, which can be found on the link to the left or the QR code to the left. Feel free to scan. On the right, we are requesting that you fill out a support survey with a few simple questions and an opportunity to meet with the team, ask us questions, or even give us guidance. That can be reached at the link or the QR code as well. Finally, we have a very special thank you to our capstone advisor who has helped guide us and support us through the past 3 semesters, Dr. Jacqueline Noggle. Thank you very much from the entire team.